Now, don't get too carried away just yet, because, I mean, the reason I'm making it a fraction is once you have one fraction, then it's easier to separate variables, right? And I do think separation of variables is going to work here. See, because what we have is we have x dv dx, right, equals to, if I've got it right here, v squared minus 2v minus 1 over 1 minus v. All right? OK, so then separate variables. What do you got? Well, you have 1 minus v times dv over v squared minus 2v minus 1 equals to what? Well, dx over x, apparently. And that's actually not a bad one, because if we make, let's see here. Well, let me just do a little bit more pre-processing here. This is minus v minus 1 dv. I like to look at it like that. Complete the square downstairs. I've got v minus 1 squared. What? Minus 2. Thank you. So anyway, but you didn't really need to do the completing the square, but the completing the square makes it just obvious that you should make a w equals denominator substitution, right? Because then dw would be 2 times v minus 1 dv. And so this becomes, if we integrate both sides, right, this integral becomes the integral of minus dw over 2w equals the integral dx over x, which gives us minus 1/2 natural log the absolute value of w plus equals natural log the absolute value of x, which gives us, what was my w? Plus a constant, right? Don't forget to add the constant. So I have, oh, wowzers. I feel like I should put that constant on the other side. So that is going to give me natural log the absolute value of w equals minus 2 log the absolute value of x plus another constant, let me call it bar, just to give it a new name. Exponentiate both sides, right? So exponentiating both sides gives me w is equal to like some, you know, plus or minus e to the c bar exponential of minus 2 log absolute value of x. And then what was w? Oh, golly. So that's it's going to take a second to unwind this here. So that's v minus 1 squared minus 2 is equal to, let me just call that k. And this simplifies to over x squared. But what was v? So we have v minus 1 squared is equal to 2 plus k over x squared. But what was v? Well, v, y over x, right? Yeah. So we've got y over x minus 1 is equal to plus or minus the square root of 2 plus k over x squared, which then gives me y is equal to x times 1 plus or minus the square root of 2 plus k over x squared. There you go. Oh, so that's why I didn't solve for y here. In my notes, I just have left it as y squared minus 2xy minus x squared equals 2k. Yay. So in my notes, hey, this is just for you guys now. In my notes, I had the good sense to not solve for y, but that's what it looks like. Uh-oh, and we're out of time. But anyway, so these are the methods. We'll do more of them tomorrow. If you guys have questions about homework tomorrow, you can bring it. Don't forget, the first stretch of your homeworks are due next Monday. I am putting more time pressure on you as to help you on test 2.
What's this method called?